These projects are designed to cultivate multiple skill sets that complement a series of videos created for the purpose of acquiring a foundational knowledge of the Python programming language. These projects will cover coding both console-based and GUI applications. tk-enter is a Python binding to the TK GUI toolkit, and its framework is built into Python's standard library, so it does not require the installation of any additional modules. This makes tk-enter a convenient choice for building graphical interfaces for Python applications. All source code in these videos is available at the 1byte@a-time GitHub repository. You will find a link to the code used in each video beneath it, in its description and comments section. You may use these links to download the source code.
This project is a Python console text-based role-playing game, or RPG. And it's designed to give you practice covering all of the basic foundational elements and structures that we will cover in this upcoming series of Python videos. So if you do this project, I think you'll find it entertaining. It'll keep you motivated. It's something you can kind of get obsessed with and lost in, and that'll kind of keep you coding. But by the time you get done, you'll have practice with lists and iterables and arrays and accessing index and subscript values and repetition structures and decision structures and nesting, both of those, and file access, saving to an ASCII file, and reading from a file, saving to a file, serializing a class, building classes, building an inheritance hierarchy, and how inheritance works in Python, polymorphism, modular functionality. You'll just get practice with just about everything that we're going to cover in this upcoming series of videos by engaging with this project. And because it's a game, you can customize it, you can theme it. It doesn't have to be, MLP based. You could do science fiction or horror or pick your favorite genre, whatever, action adventure type or something. But CD romance, but whatever, you can theme it however you like, but it will still give you the practice that you need with a lot of the basic structures in Python that you want to become proficient with if you want to become an effective Python programmer. Okay. Now, I'm not going to spend too much time going over the code in this version because it's really incomplete. Right? Be aware that this project is half-baked, but it is completely console-based, so I wanted to include it. I actually take this project and I create a more complete version as a GUI, graphical tk-enter application or game, using lots of widgets and things. A lot more code, and it's a lot more developed in that version. So I'll go over the code in more detail in the tk-enter GUI version. But in this version, I'm not going to spend a whole lot of time going through the code, but I will provide it on GitHub so that you can download it and look at it and see how it ticks, what makes it work, and hopefully get some good practice in with console programming. Now, this project is somewhat half-baked in the sense that I'm not going to spend a whole lot of time going over the code because I have a more complete version of this game as a tk-enter GUI graphical project with lots of widgets. And that one's a lot more developed, and I'll spend a lot more time going over that code. But I'm still going to provide this code on GitHub as a console-only project that can let you focus on some of those basic foundational items that you need to learn to become a proficient programmer with Python. So let's go ahead and launch our game and give ourselves some room here. Okay, so running on a while true loop, we have a main menu, and we could create a character and just engage in magic combat if we wanted to. So you can play with that option, and we have options. If I choose that menu option, here's the options here, things we can do. And I'm going to go and play the RPG, select option 4, and we don't have a character file created yet. Can't do anything, so I first need to select new game. If I had already created character files, I could load the game, save the game. Those would be options. So in our inheritance hierarchy, we have to build a class of object. And these are all derived child class objects that inherit from an abstract data type or base class object in the code. So I'll choose a Pegasus and female, of course, and Rainbow Dash, because she's the coolest Pegasus ever, right? Okay, so she has nothing in her inventory. She hasn't acquired any magic skills. Enter to proceed. Here is all her stats. Rainbow Dash's stats when she's created. Okay, instantiating 3 antagonists. So now I'm building 3 antagonists from my class inheritance hierarchy as well. And there's Bob, and there's Joe, and there's Gus. Okay, and I coded this to be really verbose so you can see what's happening. Then I'm going to generate, those are antagonists. Now I'm going to generate some NPCs that our player can interact with. And these are just lists or array type objects that are associated with each NPC, random responses. And then, when we're all done, we get to our starting location, level 1 start, and enter to proceed. And then in our game, we have our navigation options, north, south, east, and west. And there's always going to be a view up at the top, and then there will be choices. There are navigation choices, and of course, they could always select the options menu if they want to. Okay. So I come to this location, location 1. You return to the meadow with tall green grass and the dew covered grass. I see something protruding from the grass. What could it be? Investigate it? Yes. I'll go ahead and investigate it. And I find a staff, and it adds a staff to my inventory. And then I'm just going to look around again in the game, and I'm going to navigate. So I'm at center. If I walk north, see up at the top where it says location north 1, and I can navigate more, north 2, north 3. And then I can navigate back. I'm going to go south, north 2, north 1, back to the center location, south, south, south. Just showing you how cardinal directions and navigation work in the game. What about east and west? I can go east, 1, 2, 3, and then it displays the view. I can go back west and walk back to the center location and walk west and so forth like that. Okay. And then different items that I see. I'm going to go back to the center location here. And then in any game, you would want to add a cheat, and I'm going to activate the cheat mode, which will give me all the inventory items. So activate cheat mode, activating cheat mode, enter to proceed. And if I do this now, if I display my stats, I have godlike powers, it's in God mode. And if I display my inventory, I have all the relevant inventory items that I need to complete level 1 because it's in God mode. I have all the magic abilities. If I display my skills, they're all there. Okay. A God mode or a cheat mode is useful when you're coding any game because it provides a quick way to test things in the environment in the game. If you're playing as a normal character or normal player without all the abilities and godlike powers, then it's too easy to get killed before you can test different parameters and values in the game. That's why almost every game has some sort of God mode or cheat mode. Not just so that you can, go around in the game with no challenges and have godlike powers until you get bored with it, but it's for testing purposes to be able to test the game, quickly and easily. All right, so activated the cheat mode. It gave me all that. I'm going to exit and press enter to proceed. And then I'm going to go to a different location. I'm going to go down to South 3, okay? And then I'm going to bring up my options. And I'm going to save the game at this point. So I'm going to choose option 7, saving the game. So it creates character and game state save files, and it shows me the directory in which they were saved. So let's go verify that and see what's going on here. Where were those save files? In this case, project completed. Here is the directory, and it's going to be dd character rainbow dash and dd game state rainbow dash based on the name of our character. And here's our save files here. And if we open these up in a text editor, these are all the attributes, character attributes that we built when we selected our object from our class inheritance hierarchy. And these are the game state variables and values, the location and whether or not the player has found certain things. Now, I saved it in God mode, so I have all these abilities and all these inventory items, but The game state, I haven't actually played the game really. I haven't gone and obtained those items. So those booleans are still set to false. But that created those files there. Okay? And let's go ahead and let's quit the current game and let's exit. Now exiting Discord's dungeon. Goodbye. Okay? So now if we play it again, let's see what happens when we load our save file. Okay? So I'm going to here, let's do options, excuse me, and let's load the game, option 8. And it just lists the files there that, and searching for character and game state files and tells me the directory listing game files mystery. What game would you like to load? And I want to load Rainbow Dash, the Rainbow Dash game. Okay, and again, maximum verbosity. But you would probably hide this in the game, but I'm to make the code easy to follow and to make it transparent what's happening in the game as you run it. I made it very verbose, so it shows you what it's doing, loading all these values. Press enter to launch the game from the last saved position, state and stats, okay? So press enter. Look at our location. It throws us back in South 3. And remember, we cheated before we saved, so even though I haven't found anything in my inventory, look, if I display my inventory, I have all these objects because I saved it in God mode when I was cheating. Cheater, cheater, cheaters never prosper. What about my magic skills? Same thing, I have all the magic skills because I saved the game in that state, okay? And let's go ahead and exit here. All right, and if we were to walk around the game, let's just show what happens with inventory. All right, so another possible state of the game. I want to play the RPG. This time we're going to build a new game, and I'll choose Alicorn. And of course, it's Twilight Sparkle, the patron saint unicorn of, or alicorn of all nerds. All right, so Twilight Sparkle. She's got nothing. Here are her stats. Enter to proceed. There's my start location. NPCs created, antagonists created. Let's navigate a bit. I'm going to go north, and then I'm going to come back south. And when I do, there's a Boolean there that activates investigate. Yes, I find the staff. Adds that to my inventory. And if I were to choose to list that, as you can see, I'm not in, in God mode here. I don't have any of these items, although I have artificially inflated my health just so I don't get killed so I can demonstrate this. But your health would normally only be 100 when you start out. Okay, if I display my inventory, all I have is a staff because that's all I found in the game state data in level 1. And if I were to display my magic skills, I haven't found any magic skills yet. I don't have any. Okay, so I'm going to exit and let's walk around and explore a little bit. We'll use our cardinal directions and navigate some. I'm going to go north and I'm going to look east. Do I pull that out and try to read it? Yes. I found a magic skill, Ice Blast, yay! And then a Boolean has to shut that off so that in this location, let me call look again, right? I'm in North 1, and if I go east, I find the empty crevice in the stone wall where I formerly found the scroll of Ice Blast. I have to pull that item off the map so the player doesn't find it again. It has to be empty when they go back there. Of course, we're doing all this with text, but the logic is the same even if you were coding a graphic game. You have to, once they find it, or once they consume it or use it, it can't be infinite, unless it's a special circumstance, so you have to pull it off the map. So we did. And we look west and can't go any further, so I'm going to navigate further north. I'll look west and nothing around there. Oh, let me go, I'll look west and let me look east. Wonder if it's a trap. Well, let's investigate. Yay, I found a pendant, okay? All right. So, look, I'm in location north 2. Let's go further north. Now I'm in north 3. Okay. And east and west and then let's go down south. East. Yes. Oh no, it was a trap. Ah! Okay, I lost some health there. Oh well. So sad, too bad. Um, and let's look here, Hills of Happiness. And let's go. Let's try the cloak on for size. Hopefully it's not cursed. Ah, it's the cloak of princessness. Of course, Charlotte Sparkle could make use of that, right? Okay, so let's look around. And there's the Hills of Happiness. And if I look at my options, what are my options here? I display my stats. You can see that my health was deducted from my encounter with the trap. And if I display my inventory, here are the items I've found in the level map so far. And here are the magic skills that I have acquired. Okay. And if we could save the game, load the game, and so forth. Um, and then from options, I want to select option 11, and that'll just display the game map in ASCII characters. So it kind of helped, and another way you could do this, you could have this automatically display every time they go to a different location, and maybe have some ASCII character circle or, an asterisk or something mark that. But you could completely do this in the console as a console RPG, and yet you have sort of an active map or an interactive map display every place they go in the game. So this is just to show you how you could do that and to maybe give you that idea. And I'm gonna go ahead and exit out here. Okay. And that just kind of gives you a broad overview of a text-based RPG like Zork. And again, it's half-baked. It's not finished. There's lots of holes and things to finish up it. There's enough code here where you can theme it to your own theme however you like it. And then if you want, not only will this project give you really great practice with lots of different Python programming structures, but you can continue this theme and continue this game project when we start doing TK Enter projects. And I think you may even have more fun with a graphical interface, setting up a TK Enter GUI and lots of widgets and things to use with your game. That could be even more fun. And hopefully it'll keep you motivated. The biggest hindrance to learning a new programming language is getting bored with it. And then you stop practicing, you stop trying to use it, you stop coding with it. But if you can be creative, if you can work on fun projects that are hopefully entertaining and something you can feel more passionate about than just some small project that has no personalization or that no investment of yourself, no ability to express your personality, your passions, your um you know I think sometimes just having a good project, a good juicy project that can really draw you in and keep you focused and motivated for weeks or even months is the best way to learn a new programming language, because then it doesn't get boring because you make it your own, right? It's not going to be my game. You're not obviously not going to do MLP. You're like, that's stupid. MLP, who likes that? You're going to do a horror genre, a ghost or a haunted house or something, or zombies, or science fiction, or like Dead Space, or like BSG, or dreadnoughts and space battles, or maybe like some sort of government action adventure type thing. You're a government agent, Rainbow Six or something, terrorism and all that. There's so many different game themes that you could theme this out as to make it your own. And if you do that, you'll stay motivated. And by the time you get done, if you polish it and turn this project into a completed working game, and if you take it from its half-baked state to a fully baked bun out of the oven, you will have become very proficient in a lot of the basic foundational structures of the Python programming language. So I'm going to walk through this code very quickly and just give a cursory overview of it. But if you really want to see how it works, download the source files from GitHub. And when you download the source files from GitHub, there's also a zipped archive with the map, the inheritance hierarchy, things like that. But for a game like this, you're going to want to start out and just use something like GIMP or Paint uh, or Visio, whatever, to design yourself a game map and map everything out on the level, or just draw it on paper if you want. But before you start coding, you've heard the expression measure twice, cut once. So you want to position all of your traps, all of your NPCs, all of your battles and combat, all of your inventory items, whether it's magic skills or equipment or weapons and combat items, things like that. Position all of that on focus on a single level. You can always add other levels later, but it's going to take you long enough. It's going to take you thousands of lines of code just to code a small single level. So focus on that first. Try to pinpoint your focus. Don't don't let it get blurry because your goal is too broad. Make your goal small and achievable and focus on that. And then when you complete it, you can always move on and add other levels later. Okay? So once you've designed that and you have your level and your map, you can start coding it. But we have some globals here. And although it's taboo to say it in Python, pointers, what do you mean pointers? There's no such thing as pointers in Python. But remember, it's based on C++ and C. And under the hood, that's kind of what's going on here. We have some objects and they're pointing to null or nothing, as well as an array. But later we'll fill these and populate these with objects we instantiate from our class hierarchy. In this case, a heroine object and opponent objects for our antagonists. We also have some NPCs, and this is for when the player fights more than one opponent or antagonist at a time. We'll throw them into a list or an array, and then they'll have a combat sequence where they go through all of them, all of those different objects. So that's how they fight multiple opponents versus fighting just one opponent, depending on the situation or where their location in the map. Okay, and then current location nowhere. We start out, these are all the initial values, the game globals. Booleans, these have to keep track of the game state data, which is distinctly separate from the character data, okay? This is whether or not they found something, whether it appears or is visible on the map. We pull it off the map once they consume it or use it or find it. So we have to keep one set of variables to keep track of that, and that's outside the class. There's another set of variables inside the classes themselves, and that keeps track of their inventory, what they have, or the skills that they've acquired, and things that they find in the game. But it's two sets of variables. They have a relationship, one outside the classes, one inside the classes, but these are the game state data, whether or not they find something on the map, or whether it's empty, or whether they've already consumed it or taken it. That's what these variable strings and booleans are for. On the other hand, here is our class hierarchy. So this is our primary base class, or abstract data type, or ADT, game entity. And all the other classes will derive from and inherit from this class. And we try to be polymorphic, and we try to maximize the reuse of code. So it's much less coding if we can put all the things that our derived class or child class objects need in our inheritance hierarchy. If we can shift that code up into the ADT, the base class, that's just that much less code we have to type. That's just that much more code we can reuse, so we don't have to constantly reinvent the wheel. So we can, hopefully do more with less code if we code our class inheritance hierarchy carefully and shift that functionality up into the ADT or the base class. These are all the attributes of a game entity, right? All the skills, inventory items that they might find, cheat mode. That's where set up God mode in the game. Then we need, remember, a class combines what an object is and what it does. So these data members up here, that's what a game entity is. But these methods, these inner functions, that's what a game entity does. And so there's a cheat mode and display entity, because we have to see an entity. Display character, we have to display a character. It's going to display all that they have, as far as inventory items, weapons, magic skills, and so forth. All right. So in this case, that is going to display it all. But then if they just want to look at the inventory, here's a function just for the inventory. Okay. And if they just want to, equip an item, this allows them to select an item and equip it in the game. Again, you'll have to download the code. I know I'm going fast, but I'm going to go over this. My goodness, that video is probably going to be hours long. But I'm not looking forward to making it. You're probably not. But I will go over this in much more detail in the TK Enter graphical version. So again, this is just a cursory overview. So if you'll need to grab the code from GitHub and spend a good amount of time going through the code to really understand what's going on. But this will at least give you a cursory overview of the console-based, unfinished version of this project. And the bright side of it is that you don't have to know any TK Enter terminology or widgets or coding. We're going to cover all that in the upcoming series of videos. After we do the Foundation Python videos, we'll do the TK Enter widget videos and stuff, and we'll go over those widgets one by one. But anyway, this is to display the skills, all right? And notice that we're just adding or incrementing values here, accumulating values in a string, a skill to equip. So to equip inventory items and to select magic skills, there is an attack sequence built into the game entity object, and it has to make use of all their inventory items. If they select a weapon, it will adjust the point value and add or subtract damage. Defense items, attack items, inventory items. It has to look at their magic skills if they're also using a magic skill in the attack sequence, as well as the opponents. And the opponent might be employing a weapon or a magic skill for defense. So we have to calculate all that in a single attack sequence in a combat round or a combat sequence to calculate the point value that we would take from either the opponent, the antagonist, or the player, the heroine. Okay, and then we'll calculate the final amount of damage, add some randomness in there, and so forth. So all of that is in game entity, and any class that inherits or derives from our ADT game entity can make use of all that functionality. Those are wheels we don't have to invent now. They can all be displayed, they can all use weapons, they can all use magic, they can display their stats, set their stats, and all that stuff that we would want both the player and the antagonist or NPCs to be able to do in the game. So we shifted that code higher up into our inheritance hierarchy. Now here come the child or derived classes. Antagonist, and this is how you derive from a class in Python. Just pass it in, parenthetically as a parameter. Antagonist inherits from game entity. So it gets all its functionality and it just sets that. Chaos agent, okay? But it has special abilities that apply only to a chaos agent, aka Discord. Display chaos agent, specific methods that apply only to a chaos agent, as well as everything that it inherits from antagonist. And remember that antagonist inherits everything from game entity. So chaos agent gets all of that. It gets everything antagonist can do as well as everything game entity can do. Now we have a pony, which inherits from game entity, so it gets everything that game entity can do. And then alicorn inherits everything that pony can do and game entity, and things that are specific only to an alicorn, aka Twilight Sparkle. A unicorn inherits from a pony, so someone like Rarity, a Pegasus like Rainbow Dash or Fluttershy, and so they get everything that Pony has as well as everything that Game Entity has. So these are grandchildren of children of the parent abstract data type or base class, okay? So a princess inherits from an alicorn, and again, inherits, alicorn, what's our alicorn inherit from? Pony, and Pony inherits from Game Entity. So that's how our inheritance hierarchy works, up and down the hierarchy as we go. Princess inherits from alicorn, and okay, NPC inherits from game entity, and there are methods specific to conversating with or having a conversation with an NPC. Okay. Create character. Before the player can play a game, if they tried to play the game without creating a character, it would just crash. because they haven't built the character yet, so it's null value. Well, you can't manipulate or do anything to a null object. You have to instantiate objects from our class hierarchy for both the player and the opponents and NPCs and antagonists first. So that happens in create character. We give them choices, we allow them to choose, they can choose gender, they can give it a name, we instantiate it here, so we set our global, we'll call it a pointer, but it's not a pointer, but it is a pointer. And that will point to, and that will, the location of memory where our heroine object has been built, has been instantiated, okay? And you remember they chose that up here. So heroine is just calling the constructor. The way you instantiate or build a class of object in Python, you just call the name of the class as a function. And you can do underscore, underscore, and underscore, underscore, and write your own constructor, or you can use the default constructor. And we'll go over that later in upcoming videos when we actually go into detail about coding classes and whatnot in Python. Then we have to create the antagonist. So we do the same thing, and we're going to add these to a group, Bob, Joe, and Gus. We're adding them to a list, or aka array in Python. And we have to create the NPCs, and we're going to give them random, here are list objects for arrays of things that they can randomly say, as well as we'll also take string input from the player, and then we can parse it, and based on what they type in as a string, we can have decision structures go in, and the NPC can say different things to the player that's context sensitive. Maybe drop a clue, maybe just say something funny or entertaining or cute to the player inside the game. Okay, this is just a special function to format, sort of in a table fashion, the stats before a round of combat. We have pony combat. We take a player heroine and a player opponent. Okay, and that pony combat is going to go through a sequence, basically a while true loop. As long as the player and the opponent are still alive, and if they haven't used friendship cast, which would set willing to fight to be false, in which case they could get out of a fight, but if they don't have that ability, or they haven't set it, they haven't cast it, they have to fight until somebody wins or somebody loses. Somebody's health is no longer greater than 0, either the opponents or the players, and that's how we tell. So within that, we're going to, we'll basically toss a coin to figure out who goes first, and in our combat round, we'll loop it, and if it's heroine, in this case, the heroine attacks the opponent, the antagonist. Okay, we'll pause. If it's interactive, we'll let them change weapons and magic items in the middle of a combat round. But if it's not interactive, they can put it on automated mode if they want to play quicker, but then they won't get that choice. It'll just loop through and determine the stats based on their currently selected weapon and magic skill. Okay, but if they choose interactive mode, we're going to call options, and then they can choose items from their inventory and magic skills before they engage in combat. Okay, but that only applies to, in this case, the heroine, if the current player is heroine at this point. If the player is antagonist, either way, whether it's heroine, they're going to attack the opponent. And remember, attack, that's the method inside the ADT, the base class game entity. And the same thing, the opponent's going to attack the player, or the player's going to attack the opponent. And it'll just cycle back and forth in a turn-based combat sequence, okay, until we have a winner and a loser. This is our options function, just a basic loop here that displays a menu, and based on the choices, we'll call different functions they select from options. Main menu works the same way. Auto create characters, I just use that for testing. You can ignore that, but I left it in. If you want a quick way to test characters, then you could make use of this function. Play the RPG, just another menu item. If they select help, it will display this and help, okay? This initializes all of these globals for the game state, all right, are initialized, and we call that method when they decide to play a new game. Switchboard, this is our main navigation engine in the game, and it's just a long decision structure. And based on the value of current location, right, just an integer value, and these are symbolic constants, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, but it's easier to follow this. This is more meaningful to us as humans, as coders, than 1, 2, 3, 4, 5. And so we just set up symbolic constants. That's why we did that up at the top. And switchboard, we just will call that in every location. And everything that we do, when the player navigates, we're going to call this method switchboard. It's like our navigation engine. And it lets them navigate in cardinal directions based on manipulating and changing the value of current location. Here's our game map. And we just wanted to draw the map in ASCII here. All right, and you could do a similar fashion. So again, theme your game, think of your map, draw it out, and then you could even code it in ASCII like this and add that into options so they can, load and display the map from the console if they want to. Here's the starting location and booleans, and whether they're gender, male or female, so we use the proper pronouns and so forth. And then we set it to be L1 center as after they get through this introduction here, L1 start, their first location where they first appear on the map is L1 center, level 1 center. And then for every single location in the game, it's just a different function. So this function L1 center, right? If on the switchboard the value happened to be L1 center, if current location is L1 center, what does it do? It just calls that method or that function. So that's how they navigate around the game. And they're going to have a view, and then they're going to have decision structures based on, are there items, inventory items they can find, are there traps, antagonists to engage in combat with, NPCs to talk to, and so forth. All that code for each respective location on the map, we're going to code in a separate function. Just makes it modular, and it makes it a lot easier to work on a project of this size. You could code it without putting each location in a separate function, but if you did, it would just be chaos and madness. It'd be so hard to keep track of your code and modify it and figure out. So if we do it this way, if we break down every single location on that map into a separate function, then the code becomes much more manageable and modifiable and easier to keep track of and to expand. So for larger projects, we definitely want to use classes. We definitely want to use functions. We don't want to, just code everything in the main namespace of the application. There's nothing worse than an app written with thousands of lines of code and it's all in the same namespace and it's just so hard to modify and follow and expand and keep track of. But breaking things up into classes and functions, it makes it so much easier to be able to manage that project. So that's what we do for every location. It's a separate function. We're going to have a menu we have to validate whenever they find something, which is just going to be a while true loop. Okay. We'll present navigation methods. Do they want to pick up the staff? Yes or no. Or spring the trap? Yes or no. Or talk to the NPC? Yes or no. Or engage in combat? Yes or no, and so forth. And then every menu in our location is just a while true loop. And a console app. Now, when we get to the tk-enter GUI version, the logic's totally different because then it's event-based on event listeners that listen for triggers. And once triggered, it calls an event handler. And it's more random. The logic is totally different for a graphical application because it's way more random in how the user or the end user might interact with your application. So we'll see how that changes. But in the console, it's nice. We can keep the user in a holding pattern to validate, input until we get what we want or what we need from the player, from the end user. So every menu will just be a while true loop in the console. And then based on what they choose, cardinal navigation will change the value and they go, remember, they all have to be true. So as long as it's not a valid option in our menu here, then we're going to keep them, we're going to hold them here. Hey, that was invalid. You gotta give us something that's useful, that's valid. All right, north, notice it's coded the same way, right? We go through north and our north location, it's just a separate function. We do the same thing while true loop, and then if they find, in this case, a magic skill, and they acquire Ice Blast, we set that to be true. Okay. Now this is the map data. We have to set that to be true. So then we pull it off the map, and they don't find it again the next time they come back to that location and look. But this is the game entity class data. This is their actual inventory. that they found the ice blast skill. Okay, and then the navigation options and everything, that's also in a while true loop. So basically nested while true loops in every location. But South 1 is the same way. We've got our view up here. We display our view. There are options, and we go down and the navigation options, directions they can go. East, West 1, they all work the same way. So download the code, go through it. North 2, South 2, East 2, West 2. Now, I originally drew this level out as a ring, concentric rings. So you had ring 1 was like North 1, South 1, East 1, West 1. Ring 2 was North 2, South 2, East 2, West 2. Ring 3, and so forth. You could do something totally different with your map. You might not be as you know symmetrical with your map as I was. That's okay, that's fine. But you'll still want to completely draw it out first before you start coding it. And when you code it, break each location on your map into a separate module, into a separate function in Python. Same thing for North 3, and then while true loops and menus, all the validation, the navigation is taken care of by while true loops. And then here we go through South 3, East 3, West 3, and then we have a couple of other locations that they can choose to go to. Celestia's Palace, Underground, Discord's Lair. Find different items necessary to complete the game. Keys, Spring Traps, Inventory Items, Swamp of Sadness, Talk to NPCs, Mountain of Meanness, Hills of Happiness, Pegasus Citadel. These are all part of our level 1 map. Friendship Forest, Unicorn Junction, Find Healing Potion. And this is just a helper function I wrote or coded. So if they find a potion, I didn't want to constantly code this every time they found a healing potion, because there's like 5 healing potions at different locations on this level. So this saves me from having to reinvent the wheel. By making this a function, I can just invoke it and call it and reuse this code over and over and over every time they find a healing potion. So it just it enables me to do more with less code and not have to constantly reinvent the wheel. That's the idea behind classes, polymorphism, modular functions, things like that when you're coding a project in Python. Here's our save game. All right, and this goes over file access. We get the current directory, get current working directory, and that's from importing our OS module. And we're going to save, and it's based on the character's name, and we add a prefix and a postfix, an extension, to both the game state file and the character file. We could put all that in a single file if we wanted to, but I wanted to make it more transparent. I wanted to make it more verbose so you can see what's going on in the game. And then we'll go through here. We're going to append, in a character data, in an array here, all of our items that we want to save. And we just do this because it's more efficient. If I could write these one by one, line by line to the file if I wanted to, but that's a process intensive operation. It's expensive in terms of I/O, okay, on the disk. Whereas on the other hand, if I just pop all these onto an array first, I can write the entire array to the file all at one time in one stroke. And it's a bit faster that way. So you could append it one line at a time to a file, but if we add it to a list or an array first, we can write that entire array at one time and then close the file. Just a bit more efficient that way. And then when we create the game state file, we're going to do the same thing. Add all that data, instead of the character data, now it's the game state data, to an array, save it to a file, close it. For load game, we're just going to invert or reverse that process. We're going to get the current working directory. We are going to list the files in that directory. We're going to ask the player what they want to load, okay? So here, an array of files in the directory, we only want to display ones that end with .ddchar, the file extension, or .ddgame, all right, the game state or the character. But that's the extensions for our game files, for our particular app or our game project. So we're going to go through that and only display those. Which game would you like to load? We ask them. We input that goes into choice. And then choice is sandwiched between the prefix, ddchar underscore, and the postfix, which is the file extension .ddchar. And so we're going to open that file and load it for reading. Okay, and then we're going to read one line at a time. That's this read.split lines here, and save it into char data, a list or an array type object. Once we've done that, we've got all the data we need right here in this list, this array. So we can close the file. And then remember the off by one or fence post era. So this is index or subscript value 2, but it's actually the third element in the array, right? 0, 1, 2. So it's indexed that way. So 2 is actually the third element, like the fifth element, science fiction, no, but the third element. Okay, let's take a look at that. Okay, so if we open our, let's open not our game state, but our character file, and look at the third line, indexed to 0, 1, 2. The third line is Pegasus. So that tells us what we need to create. If it's an alicorn, we need to instantiate an alicorn. If it's a unicorn, a unicorn. If it's a Pegasus, we have to instantiate a Pegasus, a princess, a pony, and so forth. But we have to do this first because we cannot assign values to anything until we've actually instantiated and built a class from our inheritance hierarchy. Then when we've done that, we'll have to parse the data. All this data is going to come into us as string data, but we might have to parse it, convert it to an integer, or parse it, convert it to a Boolean to assign it to the appropriate data member of the class of object. And we have to dynamically build that object based on what we read in from the file here in this location when we load. Okay. And then finally, when we build our, we get done, heroine now points to whatever object we chose to build from the file in memory. Heroine points to it, and then we can assign that player heroine to point to that. That points to that location in memory. Okay. And then to load the game, now that we have all that set up and it's sitting there as an empty class type object, we can then go through and set all the data. So name, gender, class, so forth. It just reads everything in the text file from the order, and notice how it sequences up using these array subscript values, okay? All the way through. So it just goes line by line by line. 0, 1, 2, 3, 4, all the way down that file using a white space or line as a delimiter. And we'll do the same thing. I'll just show it now with the game state data, right? The location and whether or not we found items on the map. Okay, so now we open the game state file. We're going to do the same thing. Okay, and it's based on whatever their character name was that they decided to load. But we'll load the game state. We'll read each line in, line by line, using a line as a delimiter. We'll store it in a list, an array, game state data. Then we can close the file. We're done with it. And we have to index through the subscript values and just go through all those items in the array. Okay, and then when we get done, we built the object, we populated it with all the values, our character object, and then we've taken the game state and we've loaded all the game state data and set it. Then we can call switchboard, which will then throw them back into the location they were in when they created the save file. When they saved the game state, it saved the value of current location. That was one of the pieces of data or variables that it saved to the file. So now we use that, we call switchboard, and it simply throws them back into that location. Okay? And this is a map location template. I just threw that in the code, so it's sort of an empty bare bones. You could take that and you can customize it based on your theme for your navigation. And that's it. That's it for our console-based RPG. Again, I'll go into a lot more detail in the TK Enter version, and the TK Enter version is a lot more complete. This bun is still full of, it's half baked. The dough is still gooey, but hopefully the TK Enter widget version is, a lot more complete or are done baking. All the code, it's on GitHub, so download it, load it up in Visual Studio Code, see how it works.